Okay, we will continue with part 4 of this chapter. Okay, we are going to call it matrix operations. Matrix operations, and it will have several sections. We will see things like sum and scalar product of matrices, matrix multiplications. We will also see matrix inverses and also mechanics of matrices. And yeah, this is going to be a very interesting part of this chapter. Okay, so let's start with part A, or section A, sorry, section A, sums and scalar product. And scalar product. Part 1, definition. Definition. Okay, so okay, the scalar multiple, so scalar product. So I'm going to say the scalar multiple, not product, but let me write multiple scalar multiple. Okay, this is okay. I'm sure you can see. Okay, so the scalar multiple of a matrix is the result of entry by entry scalar multiplication. Scalar multiplication. Okay, and yeah, quite few definitions here. I should have written definitions, not just one definition. These definitions. Okay, the sum of two same sized matrices is their entry by entry sum. Their entry by entry sum. Okay, we will do some example in just a few seconds. Okay, so basically in this section where we are going to, or we are talking about sums and the scalar product, I won't split this section into two, that as the way I normally do it, like in the first video I do the lecture, and then in the second video I do the tutorial, but this is going to be a very short section, therefore I'm going to combine the tutorial and the lecture together. Actually, when it comes to the lecture, I have just two definitions and a theorem. Okay, so just give me 1 or 2 minutes and we will do some examples. Number 2, let's have a look at this theorem. Let H and G define from V to W, bilinear maps represented with respect to bases B and D by the matrices H and G, okay, and let R and let R be a scalar, and then with respect to BD, then with respect to the basis BD, okay, the map R dot H defined from V to W is represented by okay, the matrix RH and the map H plus G defined from V to W is represented by H plus G. Okay, so this is actually very intuitive. So if we have a map H and we want to find another map defined by the scalar, a scalar multiplied by that map H, then the representation of the new map, okay, RH is the same as that scalar R multiplied by the matrix representation of H, okay, big H, so it's RH. When it comes to the sum of two maps, the matrix representing the sum of those two maps is the sum of the matrices of those maps, okay, so the matrix representing the map, the new map H plus G is going to be big H plus big G. It's very intuitive, right? Yeah, a very easy theorem. Very easy. So easy. But it won't be the same thing for scalar product. Okay, so let's do. So as you have seen in the definitions, when it comes to scalar multiplication and the sums of two matrices, we add them and multiply them entry by entry. But when it comes to the multiplication of two matrices, okay, that is the result or the representation of maps composition. Okay, you will see it shortly. It's a very beautiful section. We want to do the multiplication entry by entry. Okay. So let's continue with the G section 3. Let's have a look at another definition. Zero matrix. A zero matrix has all entries equals 0. Okay. it is written, or we write, it is written as ZMN, oh sorry, NM, oh it doesn't matter anyway, let's say NM, or simply just Z. We just write it Z is the zero matrix, or sometimes or sometimes it's also written 0 and times m, or just simply 0. Okay, it also represents the zero matrix. So e.g. The zero matrix, the following zero matrix made of 3 rows and 4 columns is the following 3 rows, 1, 2, 3, 4. So that's 4 columns and 3 rows. Okay, that's the 3 by 4 zero matrix. You can also just call it Z, or 0, or 3 times 4, or just simply 0. Okay. So now let's do some examples. Example number 4. Examples. So number 1. Okay, so let me write the instruction first. Perform the following, okay, operations. Number 1, we are given 2 matrices, 5 minus 1, 2, 6, 1, 1, plus 2, 1, 4, 3, 0, 5. Okay, before we perform the operation, let's check if the matrix, if this operation is defined. Okay, we are talking about sum of 2 matrices, the sum of 2 matrices, and the definition says the sum of 2 same sized. So before we do the operation, we have to make sure that the 2 matrices have the same size. So the first matrix is 2 by 3, and the second matrix is 2 by 3. So bingo, they are same sized matrices. Okay, so we can do, and the definition tells us that we do the entry by entry sum. So 5 plus 2 is 7. 1 minus 1 plus 1 is 0. 2 plus 4 is 6. And here 6 plus 3 is 9. 1 plus 0 is 1. And 1 plus 5 is 6. Okay, so that's that one done. Let's have a look at this following operation. That was the sum of 2 matrices. Let's do the scalar product. So 6 multiply, okay, dot multiply 2 minus 1 minus 1, 1, 2, 3. Okay, what? Let's have a look at the definition. It says that the scalar multiple or product of a matrix is the result of entry by entry scalar multiplication. And here it didn't say anything about the size of the matrix. We just do entry by entry scalar multiplication. Okay, so what I'm going to do is 6 multiplied by 2 is 12. 6 multiplied by minus 1 is minus 6. 6 multiplied by minus 1 minus 6. And 6 multiplied by 1 is 6. 6 multiplied by 2 is 12. And 6 multiplied by 3 is 18. Okay, so that's good. And we will finish with the following question. So we have a combination of sum and scalar multiplication. Okay, so we have 1, 2, 3 minus 1 plus 5 minus 1, 4 minus 2, 1 equals. So first of all, let's do so we are going to write down the first matrix 1, 2, 3 minus 1 and do the scalar multiplication here. If we remember, the order of operations is a BEMDAS. Do you remember? In I think in secondary school, yeah, first year of, or second year of secondary school, we have BEMDAS, the order of operations. BEMDAS, we have bracket, exponentials, multiplication, division, and then additions first. So here we have two operations, multiplication and addition. So we need to do the multiplication before we do the addition, okay? So let's do the scalar multiplication first. 5 times minus 1 is minus 5. 5 times 4 is 20. 5 times minus 2 is minus 10, and 5 times 1 is 5. Okay, so having done the multiplication, now we can do the addition according to BEMDAS. I forgot the S, which is subtraction. Okay, so 1 minus 5 is minus 4, and here we have to do entry by entry sum. 2 plus, sorry, I'm sure I said 1 minus 5, right, equal to minus 4 for the first entry. Then 2 plus 20 is equal to 22 for the second entry. And 3 minus 10 is minus 7. Minus 1 plus 5 equals 4. Okay, so that is going to be the end of this section regarding sums and scalar product of matrices. Okay, I will see you in the next video with matrix multiplication. Okay, so see you.